Now we will study how a PN junction diode is formed and during this formation which process occur. So PN junction diode is a single semiconductor crystal with one part doping with a pentavalent and other part with a trivalent. That means pentavalent means its valence shell or it has 5 valence electrons, and trivalent means 3 valence electrons. So it is a simple an arrangement. Now if we draw PN semiconductor, suppose this side is a P and this side is a N-type semiconductors. Also we know the majority charge carriers in N-type are electrons. And in the P side, holes are the majority charge carriers. But the minority charge carriers in P are naturally electrons. Similarly, the minority charge carriers in N are holes. Electrons, majority, and in P, holes are the majority charge carriers. So when we joined or when we combined P and N-type semiconductors, then what will happen? The majority charge carriers, which are your electrons from the N side, will diffuse to the P side, and the majority charge carriers, which are holes from the P side, will diffuse into your N sides. That means the electron hole combinations will occur during this process, and that's why this process is called as a diffusion process. Now what's about the minority charge carriers? Only electrons from N will diffuse into P sides, and then the holes means positive charge carriers will remain in N sides. Similarly, the minority charge carriers, which are your electrons, remain in the P sides. Now due to these minority charge carriers, if we represent the minority charge carriers, then this will be like in this diagram. Mark the effect of the minority charge carriers. Then a junction will be developed here, or an electric field will be developed here, and that electric field will create a barrier, and the potential which will be developed due to this barrier is called as a potential barrier. Now, the current which is developed due to the electric field or due to the minority charge carriers is called the drift current. Clear? So, there are two important processes which occur during this formation. One is a diffusion process, and second one is a drift current. Now, how will you connect the PN junction diode in forward biasing and in reverse biasing? The symbol for your PN junction is like this. This is your P terminal and this is your N. If P terminal is connected to the positive terminal of the external battery and N is connected to the negative terminal, then this is called as a forward biasing. And during this forward biasing, what will happen? Here already we have discussed the majority charge carriers in N are your electrons and the majority charge carriers in P are your holes. So, when P terminal is connected to the positive terminal, then the drift current will be developed and the potential barrier will be also developed. But in this time, or for your forward biasing, the resistance will be low. Resistance will be low means current will flow, and what happens to your barrier potential or the width of the depletion layer? This layer is also called as your depletion layer or depletion junction also. Then when the current will flow, at that time the depletion layer will also be thin, and the potential barrier which is developed due to the drift current or due to the minority charge particles, that will also be reduced. Another, when the PN junction diode is connected in reverse biasing. Reverse biasing means P terminal is connected to the negative terminal and N is connected to the positive terminal of the external battery. Then this is called the reverse biasing. As we know, here means for your N side, electrons are the majority charge carriers, and in P type the holes which are considered as the positive charge particles are the majority charge carriers. Now, positive charge is connected, or the P terminal is connected to the negative, means they will attract. Here same process. Negative means electrons are the majority charge carriers and that are connected to the positive, so they will attract each other. So the depletion layer will thick during a reverse biasing. And what will happen to your potential barrier? Same electric field will also develop due to the drift current of your electron hole combinations, and the potential barrier will also be wide. And what will happen to the resistance during a reverse biasing? Reverse biasing means the resistance will also be high. High resistance means no current will flow during a reverse bias.